Here's problem set number 7. You want to solve the equation for number 1. So in order to do that, you should probably find the LCD, which is 4x plus 4. And if that's your LCD, then you have to multiply 2 on the left side to get 2x. And then on the right side, you have to multiply by 4 to get that 4x plus 4. You could drop your denominator since everything's the same at this point. So now you have 2x is equal to negative 2x plus 8x minus 12. Combine that, you're going to get 6x minus 12. Subtract the 6x, you're going to get negative 4x is equal to negative 12, or x is equal to 3. Number 2, I'm not expecting you guys to solve this algebraically. That's why I said put it on Desmos. So if you were to put this on Desmos, you just need to find the intersection. Don't give me the x value because the question is asking you to find the y value. Once you plug in a 2x cubed plus 2x minus 3 and negative 0.5 absolute value of x minus 4, you're going to find that your y value is at negative 1.75. Martha can paint a room in 2 hours. Jamie can do the same room in 6 hours. How long to the nearest 10 will it take them to paint the room together? So this is a work is equal to rate times time. We have Martha, Jamie, my together rate. They're only doing one thing, which is just painting a room. Martha's rate is 2 hours. Time is 2 hours, so her rate is 1/2. Jamie is 6 hours, which is 1/6. Together, we don't know. That's what we're trying to figure out. So I have 1/2 plus 1/6 is equal to 1 over x. Let's go ahead and figure out what 1/2 plus 1/6 is in terms of a fraction. That's going to be 2/3 is equal to 1 over x. Oops. Once you do that and you solve for x is going to be 3 over 2, which is 1.5 hours. So it's going to take them 1.5 hours to paint the room together. Now, at this point, we haven't really focused on stats that much. However, for number 4 and number 5, this should be common sense for you guys because for stats, honestly, it's just a game of common sense. So for number 4, it's asking you want to survey 150 ninth graders to get their opinion on the 24-25 bell schedule that's going to happen, in a couple of years, where we start at 9:15 to 4:10. Which of the following methods will most likely lead to a sample that is the most representative of the 150 ninth graders? Emphasis, ninth graders. A says choose 20 ninth graders from your first period class. Now, the reason why this one is wrong is because you're only looking at your first period class, not as a whole group. B, choose the first 20 ninth graders from an alphabetical list. Likewise, alphabetical list. The first 20 ninth graders might have a last name of A and call it a day. But those might be different from people that has a last name of C or F or G. C says, select 20 students at random from the ninth grade. That should say from, not form. And that is my correct answer because you're selecting students at random and you're selecting students in the ninth grade. Whereas D, yes, you are selecting students at random, but you're selecting students from each grade level. The survey only focuses on ninth graders. Since it only focuses on ninth graders, you know that it can't be D. Number 5, an advertisement makes the claim lighter shoes make you run faster. Of the following, what is the best way to investigate this claim? So A, choose records of the top 20 runners. I could already see it, top 20 runners who are wearing lighter shoes and compare their times to 400 runners before and after they began wearing their shoes. Well, if you're going to choose the top 20 runners, it's going to skew the data, of course, because, hey, they're the top 20 runners. Make sure that for number 4 and 5, you find something that is random. B, choose 20 runners and select 10 at random to wear lighter shoes and have the other 10 wear heavier shoes to run 400 meters and compare their times, which works. C, choose 20 runners at random. Okay, random. And have women wear the lighter shoes and the men wear heavier shoes to run 400 meters and compare the times. The problem with this is that you're splitting them up into women and men, but you want the experiment to be random throughout. So like B, it says that you're choosing 10 at random to wear lighter shoes. So it could be 6 women, 4 men wearing lighter shoes, and 8 men and 2 women wearing heavier shoes. Whereas C, you're kind of splitting up into men and women, which is not, it's not good. And then D says, choose to observe the results of 400-meter races for the next year and see how many winners are wearing lighter shoes. For this one, you're observing the claim. But observing the claim doesn't really make sense because you really want to experiment it. So that's why B is the correct answer. Like I said, 4 and 5 should be common sense. That's why I put it there. And you'll see in the upcoming problem sets, you're going to see more future concepts because we're not going to get to stats. And we're not going to get a lot into geometry by the end of the semester. So this is problem set 7.